This is very informal. I'm Mark Hill again, and I have joining me Nadia Bliss. I'm at Wisconsin, and she's at Arizona State. And so what we're going to do here is very informal. We're going to be computer scientists without PowerPoint, for example. I think the plan is we're each going to talk for just about 10 minutes because it's much better to have a discussion. It goes where you want to go, and it makes it much more interesting. And so I'm going to tell you some things that I think are fundamental about writing grant proposals, and I will apologize if you've already figured them out, but I think they're important enough. I'd rather redundantly tell you than if you haven't figured them out. And in many cases, you might have figured them out implicitly, but maybe haven't thought about them as much. So the first question I have for you is, what is the most creative part of doing research? Think about that for a second. You don't have to call out answers. You can be shy. Asking the right questions, picking the right problems. This is something where the general public completely doesn't understand this. They think, it's kind of drudgery. They're writing this code to solve the problem. They're not really being creative. What's being creative is that you have this infinite space of problems that you can do, and you have to pick the right problems. And this is the precursor, by the way, to writing a grant, because if you have picked some good problems, then you're more likely to get a good grant. So the second question is, if a junior person talked to you, you guys are junior relative to Nadia and I, but you're senior now relative to other people. If they ask you, how do you pick problems? Do you have an answer? Have you thought about it? I have some answers, and if you ask me, I'll tell you later. But I think you really should explicitly think about this. And in fact, one of our staff members, Helen Wright, is going to go to the Heidelberg Forum in Europe, and that's where they mix junior people with Nobel laureates. And she was asking me, what questions to ask people. And I said, go ask those Nobel laureates, how do they pick problems? So I encourage you to ask senior people, because that is the most important thing in my judgment, is picking problems. And that's actually related to, what happens when we, start figuring out what to put in a grant proposal. One of the last questions that was asked was how much should you have done and how much should you not have done? And I think that's related. So, a grant proposal, it depends on whether you're doing NSF or whether you're doing DARPA, but it's got to be a substantial thing, right? When you did a PhD thesis, that was the work of approximately one PhD student, right? This grant proposal may be a couple PhD students, or if it's a DARPA, it might be a dozen PhD students, and so you have to think much bigger. And I find that it's useful to think about, if you imagine a Venn diagram, there's a set of problems that are interesting and people would really care if you could solve them. And then there is a set of problems where progress is possible. And you're looking for an intersection, at least at the beginning. And I find, so it's useful to have a little work done. So for an NSF proposal, having 20% of the work done so that you can talk about preliminary results is useful. And sometimes I think there's a beginning of the grant where, I know how to do this. There's a middle of the work where I have some smell of how I might do it, and then there's further out stuff which I think is important I don't know how to do. And that's kind of a balance that I look for. So when you write a proposal, the naive, and as Greg was pointing out, this is really different. You're writing fiction here, right? You spend your whole time as grad students writing nonfiction, right? This experiment did this and found that, right? And this is fiction, and it's really unnerving at first, and I'm sure you guys have all written some. But I say that your grant proposal needs to implicitly answer 7 questions, and I have a web page on this, Tips for Authoring Grant Proposals. It's 10 years old, but not obsolete, and it builds on Heilmeyer catechism. Heilmeyer was a a very famous leader at DARPA who was good at asking tough questions. So the most important question I call care. Are you attacking an important problem, and if you make progress on it, will anyone care? Right? You want to make that. You want to make the case that this problem matters, and some problems you look at this and it's like, well, actually, I'm not sure anyone would care, and then you have to decide whether you want to work on it. And care doesn't mean, as Greg was saying. It could mean like security problem, very practical right at the beginning, or it could be care, you're laying the foundation that's fundamental. But someone should actually care. So remember, this is care about the problem, not like the details of your solution yet. So the second thing is, I say now. Like, why now, right? If this problem is so damn important, like, why haven't people been working on it like forever, okay? And there are good reasons why it could be why now, right? It could be that some great theoretical technique has been exposed that now makes it possible to make progress in this thing. It could be that the technology has changed, so this is a problem now, than it wasn't a problem before. I mean, John von Neumann did brilliant guy, but he did no work on cloud computing. And so, why is it important to work on this now? Because it's just much more compelling to say, you may have overlooked this problem before, but this is really important and it's growing in importance, and that's why you should fund my proposal. Okay? Now, you do need to have some ideas for attacking the problem. You can't just say, this is an important problem and we're gonna think hard. And so especially the initial part of the proposal has to outline some approaches of which the details are to be worked out, but they sort of they're a little bit compelling that this, initial progress is likely and subsequent progress is possible. Okay, as I mentioned before, even though research is in theory completely about the future, you do almost always want to have some preliminary results. So that you can show that you're well versed on this thing, and it demonstrates some other things as well that I'll come to. Okay, it's good to have a plan, right? Especially for the initial part. You want to say we're going to attack this, and we're going to attack this, and then we're going to look at that. And in industry, I'm on sabbatical right now at Google Hardware. It's not an oxymoron anymore. They call it the POR, the plan of record, and I think this is a good idea for research. A plan of record means that you have a plan, but you then balance revising the plan, some, but not too often, right? You want to revise it enough that you're not stubborn, but you don't want to revise it all the time because then you make no progress. You do a random walk. Okay, so it's
8 minutes.
Okay, so it's good. No, perfect. So, that's right. It's only fair. I was picking on Greg, and so it's important to articulate a plan. Let's see, how many more do I have here? Okay, only just 2. Okay, so the next thing is can do. If they're going to fund this proposal, you've established that this is an important problem and that you have some initial results. Like, why are you qualified to do it? And this also is very important for you, right? I mean, I know that showing that P not equal to NP is important, but I've decided that I'm not really that qualified to answer it, and so I don't work on that problem. And so, are your qualifications, are your infrastructure important? And the preliminary results that we talked about are evidence to support that. Also, your past track record as you become more senior. And finally, don't forget to do all the legal BS correctly on the proposals. In fact, my approach is always to get all the legal BS, the budgets, et cetera, done a couple of weeks in advance so that at the end I can just concentrate on getting the proposal written. However, you can't start thinking about the big ideas in the last couple of weeks. Those takes months to percolate, right? Those are really good things to do in the summer. maybe really good if you're going to submit in the fall, to think in the spring, to work hard in the summer, and then submit in the fall. The grants are a really important thing, and as Greg was articulating, they're not wasted effort, right? They're really making you solve bigger problems. Certainly funded grants are really worth the effort. Repeatedly unfunded things seem a little bit harder, but the feedback is, but don't think of them, I mean, they're what you do. And it's not just to get money, it's to define a vision. So with that, I'll turn it over to Nadia.
I'm going to adjust this for the short person. So it is super exciting to be here. I recognize some familiar faces here, so which is really nice. I'll say a little bit about my background because it's not that traditional, and I'll kind of anchor my remarks here this morning, and I am really hoping there'll be some really nice discussion with questions. So I have always wanted to do research. I wanted to be a researcher, and I've always wanted to do research since I was probably like 6 years old back in St. Petersburg, Russia. And to me, research was really, so I never thought of research as like sitting somewhere by myself, but more about working on the hardest problems and applying the most advanced techniques to those hardest problems. And as a result, I've spent now close to near 20 years of a career of doing research in security-related spaces, predominantly for the Department of Defense and the intelligence community, but also just more broadly working on security type of problems with companies as well. So I was actually an undergrad and I did my master's at Cornell. So Greg was my professor when he was a brand new assistant professor. As I said to him during the break, he wasn't nearly as humble during that time when he was an assistant professor. I think humbleness is something you acquire. I spent a decade at MIT Lincoln Laboratory. How many people are familiar with MIT Lincoln Laboratory? So MIT Lincoln Laboratory is a federally funded research and development center of the Department of Defense. It is formally part of MIT, the institution, but it sort of sits separately. It's a closed facility, so it's classified. And what Lincoln Laboratory does is works incredibly close with the US government on some of the hardest problems and applies research to those problems. So I spent about a decade there, first as a researcher, doing a lot of work in parallel computing, and then later graph theory, and then architectures for machine learning and graph theory type of algorithms. And then I moved into a leadership position, so I ran about a $25 million research group there, mostly with PhDs. And then about 6 years ago, my husband, so this is something I don't know if Greg did mention in his introductory talks, but probably many of you face your two-career households. So my husband really decided he had to be like a more traditional faculty as opposed to Lincoln Laboratory researcher, and literally dragged me kicking and screaming across the country to the desert, to Arizona State University. Everything's worked out to be okay. He gets very embarrassed when I tell this story, but it's true, so I tell it. So I spent some time as an assistant vice president in the research office at ASU, and then I've moved over, so the president of the university asked me to basically conceptualize our pan-university security-focused institute. So that's what I've been doing for the last 3 years. I'm the director of this institute. It sits at the same level as a college. We have about 150 affiliate faculty this year, so we've been in existence for 3 years, and this year we're probably going to hit about $20 million of research expenditures. We cut across all sorts of disciplines, but I am very much a computer scientist, and I have a faculty appointment in our School of Computing, Informatics, and Decision Systems Engineering. And the way that I think about security research, and more broadly, mission-focused research, so my comments tend to be more relevant to the non-NSF type of proposals, is that essentially it's the definition of work worth doing. You get to take what you know, what you're really best at, and apply it to the problems that other people really, really need solving, and often need solving in a reasonably short time frame. So we're not talking like tomorrow, but within the next few years. The other thing that I think is sort of important to point out here, sometimes there's a lot of misconceptions about what it's like to work specifically with DoD and the IC. IC is the intelligence community. The way I think about it is I've always loved James Bond movies, and that's what literally those projects are like. So you're kind of like the Q. You're not James Bond, and you're also not a Bond girl, but you are the Q in that movie, which I think is, quite frankly, pretty awesome. So with that, I think well, actually, I'll come back to this other point in a little bit. And I have also served on DARPA ISAT, so Information Science and Technology Advisory Board, which I think was actually the second time I met Greg, when he was at Harvard and I was at MIT. And it's also a great experience because you actually get to work with program managers to kind of understand how program managers at DARPA think. So what I wanted to kind of mention in the rest of my remarks is some of the rules, and maybe there are a little bit misconceptions about this type of work that may exist when people are sort of submitting proposals or thinking about proposals. So first of all, just because something is application-driven does not mean it's not basic research. So a lot of the times people think, oh, if there is an application, then it can't possibly be basic research. That is 100% not true. As a matter of fact, so DARPA, whose budget is about $3 billion, allocates about close to $1 billion to basic and early applied research. So essentially, in that type of environment, you're still open to write all your publications. There's often no foreign national restrictions on that type of work, and it really advances even the very early stages of your career. The other thing that I think is really important to highlight specifically for this kind of work is it's really focused on relationships in context of performance execution. So Department of Defense intelligence community, Department of Homeland Security, Department of Energy tend to be a lot more hands-on in their sort of interactions with the performers. They really want to check in much more frequently because, quite frankly, they are putting lives on the line. So they're literally lives at stake, and the type of problems they have you solving eventually are going to transition into the battlefield or some other application domain. So the other thing that I'll mention, and this was part of the topic, was sort of building collaboration. So within my institute at ASU, we have, and forgive my language, a very strict no asshole rule. The no asshole rule is actually a name of a book by Bob Sutton. He's a professor at Stanford in engineering management. He actually wrote this book in context of putting together a faculty search and where they are trying to decide whether to hire or not hire a particular asshole. And I think when you're choosing your collaborators, consider their technical capabilities and their research capabilities, but also consider what sort of impact they have on team chemistry. So if you have one person that is basically destructive to your team, your proposal is likely not going to succeed because proposals tend to get very stressful, especially towards the end. And then almost certainly your project will probably not succeed because you're going to need to be able to work with that person. And then the one other thing that I would say in kind of these introductory remarks is when you're working on the mission-focused problem, it's not really about you or your research, it's about the problem. So make sure that you listen to what the PMs are saying, what the program managers are saying. So one of the things that we often see, so one of the things that we do in my institute is we work with junior faculty on both Office of Naval Research Young Investigator Program and on DARPA Young Faculty Awards. And just to give you a sense, when we first started this, ASU had one DARPA Young Faculty Award over basically its entire course of existence. So we had one in like 4 years that I looked back. And then once we started this program, we've been pretty much winning 2 to 3 per year at ASU, and we've shot up in rankings from being like 34th in the country to number 6, and this year we won 3 again, so we probably are gonna shoot up in the ranking again. And you know, we're not writing those proposals. Me and my leadership team are not writing the proposals. It's you that are writing those proposals, but a lot of the times what we end up doing is we red team these proposals, right? We come, we read those proposals, and we look for how to elevate that nugget of brilliantness in context of the particular Department of Defense problem. And as a result, our success rate ends up being incredibly high. So remember this, think about the problem, think about what program managers are actually asking for. Those type of proposals tend to not care so much about, how many papers you've published necessarily, or what collaborators you've had, of what lab you've been at. They really care that you, as Mark said, have the expertise to work on their particular problem. And I think with that, I will wrap that up and open it up to questions. And one thing that I will say is, looking up those Heilmeier catechisms, I think, is a really, really good really good suggestion. I would encourage everybody to just Google Heilmeier catechisms. DARPA uses them extensively, IARPA uses them extensively, and I think they're a good idea for pretty much any proposal that you're putting together. Thanks.
Okay, so Nadia was a perfect 10 minutes. You need to go to the microphone and identify yourself.
At the University of Colorado, both Greg and Nadia have mentioned ISAT. I wonder how you could tell us a little bit more about that and how you might get on it.
Sure. Okay. So ISAT stands for Information Science and Technology. I said it before and then I forgot it. Information Science and Technology, and they call themselves a study group. Really it's an advisory group to specifically DARPA I2O. So is it Information Innovation Office now? It changes its names reasonably often. So the best way to get on it is to find some of the other folks that have been on it beforehand and ask to be nominated, or ask to be nominated or considered for nomination by some of the DARPA contacts that you may have had. You should also be good at what you do and, like all that good stuff. But it's good to identify somebody who has had experience with that particular study group. And it's actually an amazing experience from a perspective of, you get this exposure to the leadership of DARPA, and you have an opportunity to brainstorm crazy ideas in context of DARPA. So at least when I was on it, and I think it runs a little bit differently now, we basically would run these studies that would produce reports, and then those reports would be briefed out to DARPA PMs and DARPA leadership. The two studies I did was macroeconomics of cybersecurity and science of functional networks. Those were the two studies I co-chaired. And I think you get just to talk to all the people talk to you, you reach out to heads of industry and they come and talk to you. I remember at the time when we were doing the cybersecurity one, we got to talk to some really high-level folks in various companies about how they assessed risk in context of cybersecurity, and now it's a hot topic, but this was like almost 10 years ago, so it was sort of interesting to be there at that time. Is there anything else you want to add?
Right, and I was on ISAT and ISAT Executive Committee as well. So ISAT, in some sense, the founder of the CCC, co-founder was Ed Lazowska, and he was chair of ISAT before. So CCC is in some sense an ISAT for the National Science Foundation. CCC can be a little bit easier to connect to because we're more public. ISAT is not classified, but like they don't believe in stuff like a web page. No. Okay, so we tried to structure this so that it's mostly your questions. So unless we want to have a very long break, we need some questions. I'm going to ask Nadia a question while you're coming up. So Nadia, how do you pick problems?
Okay, so I'll give you kind of a slightly boring answer, though it's true. So I've always cared about the security space, so I actually spend time reading documents like the Quadrennial Defense Review and the documents that come out of the NIC, National Intelligence Council, that are public and open. And then I think about, so those are never like, we need to understand NP completeness. Nobody ever says this. But I actually think one of the most exciting things is reading about a particular problem that's happening out there and being like, oh, this connects over here to some very theoretical stuff, and how do we figure out how to take this very theoretical stuff and apply it over there? So I try, the other thing that I would say is, I spend a lot of time listening to the folks at the agencies, just listening to what their needs are. And often they're very, very open, and then I try to figure out if there's a match there.
Hi, I'm Lev Raisin from the University of Illinois at Chicago. One of your criteria for applying for grants was whether you have a plan and can do it. And I find in theoretical research, this gives me trouble on grant proposals. So in particular, you have some theorems you want to prove or some results you want to get. And if your plan is too concrete, you already have the result. And if you don't know exactly what techniques will work, you sometimes get docked, especially outside of the theory directorate of NSF, for not having a concrete plan. And this is, something that senior people also have, and I've never heard of a good answer of how to convince someone that you can prove the theorem without proving the theorem. And in fact, I can't convince myself I can do it.
So Greg, can you
Thanks.
come up here and say anything about that? I mean, the problem is in computer architecture, if you raise something to the second power, that's considered higher level math.
Yeah, so I usually have, when I was talking about the portfolio thing, I usually have a backup plan of something that I know I can do. Then, so for example, maybe I can't prove the theorem, but I can construct an algorithm that approximates it in some unsatisfactory way. But I know I can do that. And then, I write down, we will do that, but we'll also aim for doing this. And I also I'm very careful to use terms like explore a lot, as opposed to promising a particular deliverable. So I want to explore this field in which this theorem lies. It's a great open question. I mean, I think if you cast it that way, remember, at least at NSF, you're being evaluated by your peers. And so they will have some sympathy towards that. But you're right, at the end of the day, there's no great way to convince people you're going to succeed. And it's frustrating when they seem to want that out of a proposal.
So you can see what's dangerous if you hang on the audience, you may be called up to answer a question.
Hi, I'm Aruna Balasubramanian from Stony Brook University. I actually heard a bunch of things both from Greg and Nadia, about trying and getting funding from DoD or DARPA. And a lot of the times I see, something like somebody did this project with DARPA. It fits exactly with what I'm doing. I think I should get money from DARPA for doing this. But I think one of the reasons that 80% of funding in computer science comes from NSF is because DARPA is such a black box. So for example, I'm 3.5 years into my assistant professorship. And until now, I was only doing NSF. I wanted to start looking at DARPA. I look at the website, I have no idea what's going on. They have some BAAs. I send them a message. Apparently, the BAA is actually closed. They are not taking proposals. There is no way of knowing this. I don't know anybody in DARPA who I can send an email to. NSF, for example, I've been to these PI meetings, I've been to visioning workshops. I know a lot of the NSF program managers come to conferences. Tiaga, for example, almost everybody knows him. With DARPA, or for that matter, any other agencies, we have no idea. So I don't even know what they're looking for, much less who I should contact to talk about this. So do you have any suggestions for that?
Yes, I definitely have suggestions. Is it okay if I go?
Yeah.
Okay. So I guess a couple of things. I'll start with sort of internally. It's really good to identify, where's the person that asked that question? Oh, you're right there. Okay, I was like, lights. At ASU, we have a security-focused institute. So we literally have, myself and my deputy go and talk to DARPA regularly just to kind of keep our pulse on it. So if you don't have an organization like that, it would be great to identify a colleague that has been successful. So that's sort of internally where kind of you can go and talk to them and ask them for advice. And I find, as we grow the number of people, since we've had 10 DARPA YFAs in the last couple of years, we now have significantly grown our contingent of people that have DARPA experience. So then from there on, there's a couple things that's worthwhile to be aware of. So first of all, DARPA runs an open BAA, open broad agency announcement, for each office. I think that's true for each office, but absolutely true for Defense Science Office, ITO, BTO, which is Biotechnology Office, and MTO, which is Microsystems Technology Office. The open BAA is a rolling BAA. So it's very non-specific. It just says, do you have something that's in the interest of the office? What they actually tell you in terms of applying to that BAA is they basically say, if you have an idea, talk to a PM, program manager first. And this is one of those misconceptions. People think that like talking to the project manager is some sort of under the table deal. It's not at all. It's openly encouraged by project managers, program managers, and office directors. Sorry, I keep switching the term. So then if you've talked to the program manager, and the good idea is to send them an email and maybe a quick quad chart, so basically summary of your research, then often they will reach out and say, this is interesting, let's have a phone call, or they may not respond and they may not be interested. Worthwhile to ping them a second time. I think it's always good to ping them multiple times. So that's, and then if they're interested, they may say, okay, submit a proposal to the open BAA. And that way you can start a seedling program, which if it's successful can lead to a full-fledged program, to which then you're obviously way more positioned to apply later. The other thing with DARPA, the DARPA Young Faculty Award programs come out every year. I think they just come out this year, and they're a really good introductory way to get to know DARPA. And they come out with a big call with specific topics. So if your research doesn't apply to a topic, don't apply, because DARPA cares about the specific topics they've listed, but then also have someone review your proposal before you submit, someone that's had experience with the DoD. And then if you want a Young Faculty Award, typically that positions you for further success with that program. Does that make sense? Yeah, okay.
And I guess I would add that you have a logistics?
No, go ahead.
I would add that the person that is connected with DARPA doesn't have to be at your institution, right? You can talk to somebody that's in your field that you know very well. But in my experience, it doesn't work to submit a gigantic proposal to a BAA with no talking. I mean, it's going to be a waste of your time. You need to get a foothold.
And just for everyone to be aware, tomorrow, the kind of how to work in policy and with DC, we are going to have people from different agencies, including DARPA and IARPA here. And even if that's not the right person, it's still an entree. And also getting involved in things like CCC visioning workshops and bringing ideas and white papers to us, because even if we don't have the direct contacts, a lot of our work does get reported out to those agencies. So it's another thing you could say, I was involved in this work that was brought to your agency, and I'd love to extend it further with you. So it's, while you might not have the right person right away, just doing service broadly can really help in that way.
And Bill Regley, who's representing, he was at DARPA, he's going to represent DARPA tomorrow. He has a great slide deck, like DARPA 101.
So Greg mentioned broader impact section. I don't know if that's only NSF. Oh, I'm Lydia. Oh, y'all know me. I already bothered you. So I got roped into one of these NSF expedition things, and there were 12 senior faculty members and me, and they're like, oh, now we need to write broader impact, and everyone looked around the room, saying like, who knows how to do this? Like, nobody knew what this section was about. We read the website and went like, this is not how this is supposed to go. We should not be reading the website to figure this stuff out. So I guess now's my chance to ask, what sounds good, and that, like, what are they looking for? What's a good thing to say? What's a bad thing to say?
Well, I mean, NSF is actually quite serious about trying to have broader impact. So, I guess, if you're desperate, you can just sort of check the box with some safe things, but what they really want you to do is band together and do something real. And I think, Greg gave a good example where by creating that Sonic program and, the amount of work probably that each faculty member had to do was small, but they got virtual credit for the whole program. That's a good, that's a good example. If you're going to do something minimal, you can talk about, relations with industry, relations with undergrads, and things like that. But I think it's a really it's one of those things. It's a good thing to do, and it's in your selfish best interest because it can be a tiebreaker on funding your proposal.
Yeah, please.
Use the mic because we're recording.
So that RoboBees project I mentioned, one of the reasons I think it was successful is for broader impacts. We joined up with the Boston Children's Museum to develop some exhibits that traveled around the country around both robotics and bees.
Wait, did you say you were going to do that, or did you do that?
We said we would do that, and we did that.
Oh, wow.
And so I think that's the kind of out-of-the-box thinking, is something that really engages the community. If you think of it from NSF's standpoint, they have to go to Congress and justify your research. And when you're looking at dependently typed compilers or whatever, they can't sell that to Congress. If you can have an activity that really couples with the research, but engages with the general community, I think that's when NSF wins the most, and then by virtue you win.
Hi, my name is Hian Nguyen. I'm from University of Houston, and thank you so much for organizing this event. I have a question about, I have a plan for your proposal. So basically what I find is that a lot of colleagues come to team up with me to write proposal. But in order to have a convincing proposal, you need a lot of preliminary data, like especially for NIH, there's a lot of work to be done. So how do you, as a new faculty, we have only like 3 PhD, for example, and each of them have to take courses and they're not fully capable to do a lot of work. So how do you balance between, doing the research that you really care about and generating, the work that generate the preliminary results for all sort of proposal, like different agencies have different type of, work and then different requirement for preliminary results. So that is the thing that I find quite challenging to manage, and I hope that you can maybe provide some insight on that.
Well, I guess I'm a computer architect, and so in architecture you process an instruction through multiple stages, and we start processing the next instruction even before we finish the first one. And I actually think this model is kind of reasonable for research. So research goes through a number of phases, and you have to spend some resources starting the next project while the current project is still active. And so you do have to spend time identifying the problem and gathering some preliminary data basically on the previous grant in order to get the next grant. And of course, as a new professor, the previous grant is your startup funds. One of the reasons that you're given, sort of 6 or 7 years to get tenure is that if you sort of have some hiccups in this startup progress, it's okay. So it's more important at the very beginning to, be getting the groundwork and laying the foundation for that great grant and the great work that you're going to get out in 7 years than it is to make sure you have publications coming out your first couple years.
I think also, there was something in there that you said that how do you balance sort of the real research versus the preliminary data? So I think it's really helpful to map out what your research vision is, right? So when you get success.
Please follow all instructions, as this will not be a test. Thank you for your cooperation.
Okay. So ideally, you've mapped out sort of a research plan, so that requires you to generate some preliminary results. So your preliminary results shouldn't be throwaway data, right? It's kind of early results for what you would like to do eventually, anyways, right? So if you have this plan, so I'm going to do this experiment first and then this experiment later, maybe that first experiment is funded by your startup funds, but it potentially is something that also generates a publication for you as you're applying for that bigger grant. The other thing that I would say is I've certainly seen this in a number of proposals that I've participated in and have shepherded, is, especially for agencies like NIH, which are very investigator experience centric, it is really helpful to partner with someone senior who has had significant NIH experience and will already have some preliminary data that could be used to sort of start off the proposal.
Thank you.
And, regarding partnering, there are some issues with partnering pre-tenure, like, for example, if you partner with somebody senior that's in the exact same area of you, it can be, those publications might not count as much, but you're going to do other work. You can certainly partner with somebody who complements you. After tenure, all bets are off. Your job is to do great work, and, if it can't be attributed to you, the pay raises in academia are so damn small, who cares, right? You want to do great work.
Hello, everyone. Is this working? Yeah, okay. I'm Leila. I'm going to be a faculty at University of Delaware, so I'm one of those first-year faculty members. Hopefully, I will be successful next year. But my work is in the area of human-centered computing and HCI, and my research is highly collaborative. So I have a big challenge of saying yes and saying no to collaborators, and I'm kind of one of the few handful number of people in the university who's doing HCI research. So I have so many people coming and talking about some ideas and also some ongoing projects which I can jump into and I don't have to do so much work, but I can kind of get some contributions, small contributions. So it's a little bit of challenge for me to decide what is the boundaries, where I can do my own independent research, where I can collaborate with a portion of it. So do you have any advice on that? And thank you.
Okay, well, that's not a simple question. It's related to what Greg said about you have to say no a bunch. I would encourage, talking to a lot of people, having lunch with them, having coffee, exploring connections. The real question is when you go further and sort of agree to collaborate. And you need to be very selective on this. I think the key that you want to identify, one of my colleagues used to give advice on assistant professors, put your own oxygen mask on before helping others. You have to be a little bit selfish as an assistant professor. And so you need collaborations, a bad collaboration is where you're kind of the programmer or the advice person for some other person's research. You want something that's, it's really transformative in both your fields. And so I don't know if I have perfect advice on this, but you want to say yes selectively. I mean, do a lot of exploration, but when you go forward, you got to be selective, because if you go in too many directions, you're likely to thrash and get nothing.
I think it's also good to consider, what is that collaboration bringing you besides research, right? So if this is a collaborator that you can see as someone who could be a mentor or a peer mentor, that may be worthwhile to pursue, even if it's a really small part of the project. The other thing that I would say, is to the earlier question about, getting to understand DARPA. So if this collaborator is going to be able to introduce you to an agency that otherwise you would not have been able to get introduced to, that's another worthwhile opportunity to pursue. I also see this sometimes, which I really don't like, is there'll be a big proposal and the junior faculty will be stuck writing the whole proposal, and then a senior faculty gets the credit. That's bad. That always walk away from that. That goes with the no asshole rule. That does not, pass the no asshole test. And usually you can ask other faculty about experiences that they've had with various collaborators. People tend to be pretty straightforward, and you kind of learn your way around that.
Eleanor Barrell, Pomona College. So one of the funding sources that's been mentioned a couple of times is funding from industry. So to what extent does the advice you've been mentioning so far apply to both finding funding opportunities with industry and to putting together a proposal?
I can comment on that. I've had a lot of funding from industry. David Patterson was my advisor. He was even more successful than me at funding from industry. But so industry tends, I guess there's various types of industry, but the part that I'm most familiar with, the funding tends to be sort of much smaller, unless you're David Patterson. And so it doesn't run your research program, but you can get, I mean, Google, can give you like up to $100,000 a year. Sometimes it's smaller than that. And that's really good money because it's a donation, it doesn't have overhead, it doesn't expire, so you can spend money that expires first and then use this as a sort of safety net. Now the key is that I don't think industry really gives any funding to sort of cold proposals where you just submit to their program. It always requires you taking the time to get to know somebody in the company, who will be your advocate, to say both that you do good work and you pick important problems. And so the way you can start that ball rolling is to meet industrial people at conferences and offer to give talks. And I think, as with many relationships, if you lead by asking for money, people are going to shut down. So work on building the relationship, and then after a year or more, you can start looking at the money thing. And also, by the way, industry contacts can be valuable depending on your field for much more than money, because they can tell you, no, that's not really the hard part, but the hard part is that. And they can point you to things like that. In fact, I find industry connections so valuable that I'm in my third sabbatical in industry, because I like to go to the computer industry, the hardware industry that I'm in, to find out what's happening. And I can't take away from them their solutions. That's their intellectual property. But I can take away problems that are just emerging. And you can also do that in a less intensive way by sending students for internships.
I think for the most part, almost everything I have said applies to the industry collaborations. I would also put foundations in that bucket as well. So I actually had a note to mention. So we just recently finished a project. It was small. It was smaller than any DARPA project, but in terms of funding scale, but in terms of impact, I think it could be pretty significant. We just recently finished a project with Leonardo DiCaprio Foundation, which was focused on sort of optimization and visual analytics, computer science and industrial engineering project, 100% for conservation. And it was an incredibly interesting problem that the professor that led this has never worked on before. None of them were conservation experts, they were computer scientists, but they listened to the foundation, and there was sort of myself in the loop kind of making those connections. I would say, just to mirror a little bit of what Mark said, universities usually have industry relationship and foundation relationship groups. Understanding how and whether they function is important, because if they're functioning really well, then they're a tremendous resource. And they can kind of help you out with those connections. I will say we have a pretty significant partnership with Allstate at ASU, again focused on cybersecurity, computer science. It's all computer science research. We do, in addition to the faculty that are doing the work, we have someone on my leadership team that kind of serves as a relationship manager and interfaces with the folks at Allstate. And we, for example, had a situation where the faculty that was doing the work wasn't really doing what Allstate was interested in, but they still wanted to fund us. So we identified a different faculty that had the type of thing that they were interested in, and now they're funding that person. So, but a lot of it comes down to understanding, what their problems are, and really appreciating what their problems are, and listening to them. And the more you end up being successful, the easier it is to become successful. It's that first connection that is hard, which I understand is what we are asking. So asking somebody to make that introduction, I think, will help a ton.
Thank you.
Okay, so we'll take one final question, because I'm a big believer in the parallel communication that breaks enable.
So my name is Omar Chaudhry from University of Iowa. So I wanted to ask a little bit about career awards for the NSF. And so a lot of advices I got was to be a little bit of ambitious. Now, what is the right line? Now, say I've been working on a general theme, and I'm planning to use new technologies that I've not used before. So how do I argue that I'm the right person to do this? Does it mean I have to show some publication to show support to that, or are there other advices you can give me?
Is this an NSF question? Because I can't really talk to this in context of NSF, but I would encourage you to identify a collaborator and then go for it. You don't necessarily have to have a collaborator, but I've seen DARPA fund people that have not had experience in a specific area based on the fact that they were addressing the problem, and they sort of believe in that risk taking. Agencies like DARPA tend to be a lot more focused on the problem as opposed to the investigator, right? So if you are showing reasonable probability that you can address the problem, I'd say go for it. But my general answer is just go for it. So maybe I should temper that with Mark's. Yeah.
Well, first of all, I should disclaimer. I applied for the equivalent of that award, 30 years ago. So things might have changed a little bit. I think it's good to have some evidence, but it doesn't have to be a lot of publications. Even one publication. I mean, it's articulating the problem and why it matters to people is something that's not done as well in many proposals. And you can really stand out by answering this: why should people care if I do this? So with that, thank you for your attention, and we're going to have a half-hour break and resume at 11 o'clock with parallel sessions on career planning, taking hurdles in stride, and also networking, building your research village. So have a half hour for networking, food, and bio break. Thank you.